Hi, this is going to be a three-part series on a particular concept that is kind of difficult to find at first, but is has a variety of ways to finding it. This is about how we are supposed to find slope. So all we're trying to do is find slope. The reason why it's going to be a three-part series is because there's three different ways to find slope. There's a variety of ways that we can look at it. But for the first part, we're going to talk about how we find it through a table. A table is probably the easiest to recognize just because we have different changes associated with the x and y values. So for a table, we're going to do the following example. We have x and we have our y output. X is our input while y is our output. If we remember what that means, that basically means there are certain x values and there are certain y values that go and associated with them. We're going to have the following. We're going to have -3, then -1, then 1, then 3, then 5, and it keeps on going. Meanwhile, for the y, we're going to have the following. We're going to have 0, 1, 2, 3, 4. Now, in order for us to find slope, we have to remember what slope is. To recall what slope is, we're always writing it as rise over run. Well, rise over run doesn't really help us here because what does that ultimately mean? Well, rise is always associated with this thing called a change in y. I mentioned to my classroom that the slope is always considered as a ratio of change. And so we have the example with rise because our graph has the change in y. Meanwhile, our run has this thing called a change in x. So what I'm going to look at is just the change in y and the change in x. So what I have for x is I have to notice the change in between the different inputs. One thing to note is what is the pattern that's happening each time. How is it going from 1 to 3? How is it going from 3 to 5? If I look at from the -3 to -1, that's going to be +2. We're going to go from -1 to +1. That's also +2. And we're going to keep on doing that. How do I go from 1 to 3? That's also adding by 2. Well, 3 to 5, also adding by 2. Well, that's the change in x. X each time, if I go down, is that it's changing by 2 each time. Let's notice the y. How much is y changing by each time? If I'm looking at this from 0 to 1, I notice that I'm changing it by 1, such as the following. How do I go from 1 to 2? Well, I can do 1 plus 1. What about 2 to 3? I can also add by 1. 3 to 4? Also add by 1. So I'm noticing that this is what we call a consistent change. So it's constant change. So it's a constant change for x and y. We can see here that x is constantly changing every time when we add by 2. If I notice by y, I notice that it's also changing by 1 each time. Well, now, let's see if we can find the slope then. Well, slope is, in the linear equation, it's called m. So we're going to figure out the change in y over the change in x. So I mentioned that there's a consistent change in x and y. So we're going to look at the each of them separately. So change in y over the change in x. Let's look at the change in y. How much is y consistently changing as I look at the different values? Well, we can see here we have a +1 across all of them. So that's exactly what we're going to do. We're going to put +1. I didn't add them all up. I just looked at the number that it's constantly changing by. Let's notice now the change in x. Notice that's going to go on the bottom. I notice that it's constantly changing by +2 each time. So I'm going to put +2. And that's my final answer. It's 1/2. So because we have a constant change for x and y, we are able to find the slope. Let's find maybe a counter example for us to see what is a slope if it doesn't have a consistent change. So let's say I did -2, -1, 0, 1, and 2. But I did the following. I did 3, 4, then I did 6, then I did 5, and then I do 7 again. A little bit of a switch up, but let's see what I can do. I notice that x is changing each time by a particular number. How do I go from 0 to 1? How do I go from 1 to 2? I notice that they're all changing it by 1. So I'm going to put 1 on the side, just like this. Well, let's ask ourselves the same thing. How do I go from, 3 to 4, 4 to 6, 6 to 5, 5 to 7? Well, let's ask ourselves, how do I go from 3 to 4? I notice that with that one, I can just change it by 1 each time. What about 4 to 6? Well, from 4 to 6, it's going to be plus 2. And then how do I go from 6 to 5? Well, this is minus 1. And then how do I go from 5 to 7? Well, that's also plus 2. Let's see if this even makes a graph. So what I'm going to do is that I'm going to graph it and see what happens. So here I have my graph. And then I have this as the following. So at negative 2, 3, so I'm going to count by the numbers. 1, 2, 3. And then negative 1, 4, which is right here. And then all of a sudden, I'm going to actually do this in blue. So we're going to repeat that again. Negative 2, comma 3 is right here. Negative 1, comma 4 is here. 0, 6, so I'm going to count it. 1, 2, 3, 4, 5, 6. That doesn't really line up. Let's try it again. 1, comma 5, and wait a minute, it's right here. What about 2, comma 7? Okay, it's right here. So it doesn't look like it actually makes a line. If I try to draw a straight line like this, it doesn't go through all the points, right? Notice because of that, it's not a constant change. So this is an example of not a constant change. So because this is not a constant change, we can see it on the graph. Because this is not shown in the graph, this is not a linear equation. So therefore, that means it has no slope as the answer. So notice that that's going to be it for our table. When we talk about slope in this part 1, we notice the change from x and y. But the key part of this is that it has to and must be constant. It must constantly be changing all the time. And because it has to be constantly changing over time, you have to notice if it's always adding or subtracting by the same number. It could have been plus 1, it could have been minus 1, it could be minus 5, it could be plus 100. Regardless, it has to always consistently be that way. If you look at this, however, you can see that it's not changing each time by a consistent amount. Rather, what's happening instead is that it's always changing a few times. That's basically it for this video. In the later videos, we're going to be talking about how to find slope through other two means.